Okay, for this lesson, you're going to need your book, and we're just going to follow along with the rules introduced in this lesson. And I don't have a handout for it. We're just going to use some pencil and paper and work some of the examples. So, this particular section is going to give you some rules for taking derivatives that make life a little bit easier, where you don't have to use the limit rule every time to take a derivative. So you can find the derivative of a constant function. We're going to take a derivative using the power rule. Find the derivative using the constant multiple rule, sum and difference rule, and the derivative sine and cosine. And then next Tuesday, we'll start rates of change. So the first rule, the constant rule, is the derivative of a constant. Now remember, a derivative just means slope of the tangent line. So if you were to sketch a tangent line along this constant, y equals c, the slope would always be what? 0. So the derivative of a constant is 0. And then they go through the limit process to show you that the derivative of a constant is 0. Here's the derivative of y equals 7. Notice the derivative notation dy dx equals 0. Here's another constant function, and we can use it as f prime. So they're exposing you to the different types of notation to represent a derivative. But the derivative of a constant is always 0. All right, turn the page. Now, here's the limit definition, how we use it to determine the derivative of a function raised to a power. And we're going to have to expand this big old polynomial and then factor out and then cancel out the denominators to use the limit rule. But instead of going through that process each time, we notice that something always drops out when we use this particular rule, when we find using the limit rule. And so we kind of shorten the limit definition of a derivative to called the power rule. And this goes in the whole explanation of how it shortens. It gives you the whole proof of it. But basically, this is all you need to know. The derivative of a function of x to the n power is equal to, you bring the exponent down in front, multiply it times the function, n times, and then you subtract 1 from the exponent. So, for example, let's look at a couple examples. Let's find the derivative of each. I'm on page 109. I'm going to use example 2 as my guide. So I'm first going to find the derivative of x cubed. All right, so the derivative of x cubed means I'm going to, following the rule, and the rule says taking the derivative of a monomial term, one variable term raised to a power. The power is a number. The power comes in front, n times x, and you subtract 1 from the exponent. So in this case, n would be 3. So the derivative of this monomial term, just this one term of a polynomial, would be 3 times x, and then subtract 1 from the exponent. So the derivative would be 3x squared. So let's say that I had f of x equals 4x to the 5th. Let's find the derivative. This time I'm going to use derivative notation. Instead of d dx, I'm going to write as f prime. All right, so using the rule says bring down the exponent and multiply it in front. Here's the exponent, 5. I'm going to multiply it in front, so 5 times 4x, and then subtract 1 from the exponent. So derivative of 4x cubed is 20x to the 4th. Let's look at another example. Let's find the derivative of, let's call this one g of x, cube root of x. Now, before you find the derivative, you can go through the limit notation, but it'd be awfully nice to use the power rule. And to use that power rule, I'm going to need it in an exponent form. So let's rewrite this as a fractional exponent, x to the 1/3 power. Now I'm going to use the power rule to find the derivative. I'm going to take the derivative, the exponent in front, 1/3 times x, 1/3 minus 1. I'm going to do a little bit of algebra here. Can't just leave it in that form. So 1/3 x, 1/3 minus 3/3. So the derivative is 1/3 x to the negative 2/3. And to write that in simplest form, I'm going to write it as 1/3x to the 2/3 power. 3's in the denominator, negative exponent takes it down to the denominator. All right, now, what if you had y equals 1/x squared? Again, it's a little bit easier if it's written in a form. I can use that power rule. So I'm going to rewrite it as x to the negative 2. I'm going to bring the form out of the denominator so I can use the power rule. Now let's find the derivative. The exponent multiplied in front, negative 2x, negative 2 minus 1. That's negative 2x and negative 3rd power. And we can simplify that a little bit more. We can go write it in fraction form. So let's try this one. What if I had f of x equal 4/5 x to the 3rd power? Find the derivative of that one. So I hope you recognize that 4/5 is a coefficient. So I'm going to bring the x up to the numerator with a negative exponent. So it stays 4/5 x to negative 3. Now let's find the derivative. So it's negative 3 times 4/5 x to the negative 4. So in simplest form, it's just negative 12 over 5. And let's go ahead and bring that x to the denominator. Negative 12 over 5x to the 4th. All right. Now then, remember, if you're given a function, the slope of a function at a point, which means one location, is the slope of the tangent line. But we don't want to write slope of the tangent line every time. We want to say something a little bit simpler. So given a function, the slope of the function at a point is, and we know another word for slope of tangent line is the word derivative. So given a function, the slope of the function at a point is the value of the derivative at that point. So let's say if we had this. Let's look at an example. Let's say that f of x equals x to the 4th. Find the slope of f of x at x equals 2. Go ahead and try that. So if I want to find the slope of the function at one location, I'm going to find the value of the derivative at that location. So first I've got to find my derivative. So f prime, using the power rule, is 4x cubed. And then the slope of f at x equals 2 is f prime of 2. So let's find that value. 4 times 2 cubed, so 4 times 8. So the slope is 32. So it climbs pretty quickly. It's a very steep curve at 2. So the slope of f of x equals x to the fourth at x equals 2 is 32. All right, let's go back to your book. Let's look at example 4. Find the equation of the tangent line to the graph of f of x equals x squared when x equals negative 2. Find the equation of the tangent line. So you've got to remember, what do you need to find the equation of a line? You need slope and a point. So you can plug it into point slope form. All right, that's what you need to find the equation 1. The one in example 4 says find the equation of the tangent line to the graph of f of x equals x squared at x equals negative 2. All right, so I know that f of x equals x squared. I want the equation of the tangent line. And I know that the slope of f of x at x equals 2 is equal to the slope of the tangent line at x equals 2. All right, so then let's find the derivative of f of x will be 2x. The value of the derivative at 2 is going to be 4. Now I need a point, so here's my slope. Where's my point? Well, I know that the tangent line's got to contain that point at 2 on the curve f of x equals x squared. So let's find f of 2. F of 2 is 2 squared, which is 4. So my slope is 4. My point is 2, 4. So let's plug it into y minus y1 equals m times x minus x1, point slope form. So y minus 4 equals 4 times x minus 2. You found the equation line. You don't need to do anything else unless you're asked to do it. It's kind of nice to put it in function form in case there's something else you need to do. So y equals 4x minus 4. And notice I worked a different value than the example form in the book. They found the equation tangent line at negative 2. I found it at 2. So it's a little bit different example. All right, turn the page in your book to 110. And we've already kind of worked this rule. And it says if you have a function and you have a coefficient in front of it, then you take the derivative. Well, then you still use the power rule. You just multiply it by the coefficient in front. For example, look at the example. Let's work another example. Let's say f of x equals 4x squared over 5, like we were working earlier. Okay, so the derivative is just going to be 2 times 4x over 5. And there's nothing else I can do to that, so that's just 8/5 x. But let's say f of x equals 2 square roots of x. You're going to want to use that power rule, so I'm going to write it as x to the 1/2 power. So the derivative is 2 times 1/2, x to the 1/2 minus 1. So that's going to 2 times 1/2 is just 1. So that leaves me x to negative 1/2. And I'm going to write that as 1 over x to the 1/2. And you don't have to put it back in the radical form. Leave it as a fraction. Okay. Then, if you have the sum and difference of two functions, you just can take the derivative of each function. If you have the difference of two polynomials or monomials, you can just take the derivative of each of those functions too. So, for example, if they're all kind of put in together, let's try one. So, f of x equals x cubed minus 4x plus 5. I don't have to take that, I don't have to separate it. I can just go and take the derivative of each piece. So I'm going to use the power rule here. So that's 3x squared minus 4, and the derivative constant is 0. So the derivative is 3x squared minus 4. So I did that kind of fast. I'm taking for granted, but you realize that the exponent that here is 1. 1 times 4 is 4. 1 minus 1 is 0. Anything 0 power is 1. So I'm finished with the derivative. All right, let's try another one. G of x equals negative x to the fourth over 2 plus 3x cubed minus 2x. Go ahead and find the derivative. You just find the derivative of each piece individually. All right, I'm going to use the power rule for each one. Negative 4 over 2 x cubed plus 9x squared minus 2. So that's a negative 2x cubed plus 9x squared minus 2. There's your derivative. Now, the next set of rules that are most important is the derivative of sine. The derivative of sine is cosine, and the derivative of cosine is negative sine. And it's best if you just memorize those. So, for example, let's say f of x equals 2 sine x. Then the derivative is 2 cosine x. If f of x equals 2 cosine x plus 3 sine x, let's put it together with combination with another one. The derivative is 2 times negative sine x plus 3. The derivative of sine is cosine x. So the derivative is negative 2 sine x plus 3 cosine x. Okay, and we'll work on the homework during class.